Okay, so let's see if we can make sense of this graphical question. So in the box presented to you in the problem, they show you a reactant cartoon and then the product cartoon. Now let's start with the reactant. The reactant is described as having atoms of iodine and atoms of nitrogen. And they tell you that the nitrogen is represented by blue and the iodine is represented by purple. Now I had a hard time distinguishing the two colors, but because I'm colorblind, by the way. But nevertheless, I can see that what they intend to depict here is a molecule of Ni3 or nitrogen triiodide. Mononitrogen triiodide is another name. Regardless of the name, this chemical formula for each of these cartoons is Ni3. Let me write that down. Now, the number of molecules here does not represent the actual number of reactant molecules. It's just a cartoon, in this case with 6 molecules, but that doesn't mean that you're going to have 6 of these. The only thing that this means is that you have Ni3. Now they tell you that the reactant is a solid. So we need to write that down. So this is a solid. And there's no second reactant. So this is a decomposition reaction. Ni3 is going to decompose into 2 products. Now, what are the products? Well, here is something important to notice, and it's not very clear from the problem. But here they say actual products, which means they're telling you the actual amounts, most likely, of the products. Now, why is that important? Well, because in the problem, they're going to be asking you for percent yield. In other words, not every reactant molecule is going to decompose into the products. Only some of it will. Now, let's take a look at what we have here. Once again, looking at the color code, you have N2 and you have I2. So let's put that as the products. N2 plus I2. And you are also told that these are gases. So let's indicate that by the gas. Now, at this point, we need to write a balanced equation before we even proceed with the problem. But that happens to be, in fact, the first question of the problem. The first question of the problem is to write a balanced equation for the reaction, expressing the answer as a chemical equation, and identifying all of the phases in your answer. So let's balance this. We have 1 nitrogen on the left, on the reactant side, 2 nitrogens on the right. So we need to do something to balance that. We're going to put a 2 here. Now with that 2 there, as you learned in an earlier chapter, 2 times 1 gives you 2 nitrogens, 2 times 1 gives you 2 nitrogens. But now we look at the iodine. We have 2 iodines, I2, and we have 2 times 3 iodines, 6 iodines. So we need to balance that by writing a 3 in front of the I2. This now has 3 times 2, 6 iodines, the same amount as the reactant side. So this is the answer to part 1. 2Ni3 in the solid state yield 1 N2, 1 mole of N2 gas plus 3 moles of I2 gas. Now the second part is more challenging. So this is part A, the balance equation. Part B, they want from the diagram of the actual products, so actual products, they want you to calculate the percent yield of the reaction. So calculate percent yield. Now the actual drawing, if we look at this picture here, has I'm gonna count as best as I can, 1, 2, 3, 4, 5, 6 of these iodine molecules. 1, 2, 3, 4, 5, 6 I2s, which are in fact purple. And then it has 1 and 2 nitrogens, 2 and 2s. So with that, we need to do a calculation of the percent yield. So if we look at the diagram of the products, we can write that we have 2 N2s plus 6 I2s. Now, here's where the problem gets a little confusing as far as what answer you would expect. Because since we are not given the amount of reactant, so the reactant has to be the limiting reagent, since the balance equation produces only 1 N2 for every 2 Ni3s. Now, theoretically, to get 2 N2s and 6 I2s, you would have to start with 4 Ni3s. The percent yield is calculated by dividing the actual yield over the theoretical yield. And then multiplying by 100%. So if we do that for nitrogen percent yield, the actual yield was 2 moles. 2 moles of N2. The theoretical yield is 2 moles. So the drawing, the picture here shows you 2 moles of nitrogen, and theoretically, according to this balance equation, we should have obtained 2. So the percent yield for this reaction then is 100%. 2 divided by 2, 1 times 100, 100%. If we do the same for iodine, the actual yield according to the drawing is 6 I2s. The theoretical yield for the balance equation would be 3 starting from 2, but here we need to assume that this is plentiful, not limiting, so it would be also 6. Therefore, the theoretical yield would be 100%. Now, if when you solve the problem, this is not the answer expected, I will give you credit because clearly there is a problem with the problem, or a mistake rather. I hope this sort of helps with this question. I'm going to make sure that hopefully it's not on the final, but I'll remove it if it is. Thank you.